If you know how to do multiple stoichiometry, but you aren't sure where to start when a problem gives you grams, this video is going to show you exactly how to handle that. Now, remember, all stoic problems are going to use the stoichiometry roadmap shown here. And so just to quickly review the stoichiometry roadmap, we always want to start with a balanced chemical equation. If the problem gives us our known value in grams, then we have to convert that into moles first, using moles is mass divided by molar mass. And then we use our mole ratio between our known and our unknown substance to get the unknown substance number of moles. Now, this video is just going to focus on the first 5 steps here, but if you needed to, you would then convert back to grams or whatever units you needed for the problem itself. Let's just jump right into an example then. So we have sodium carbonate reacting with hydrochloric acid to produce carbon dioxide gas, water, and sodium chloride. We're asked to calculate the moles of sodium chloride produced when 50 grams of sodium carbonate reacts. So let's just take our handy dandy highlighter and highlight let's use blue, what we're looking for. So we're looking for moles of sodium chloride, and then we are given 50 grams of sodium carbonate. Step 1 then of stoichiometry is always a balanced chemical equation. So sodium carbonate is Na2CO3, and that's going to react with hydrochloric acid, HCl. That's going to produce carbon dioxide gas, water, and a sodium chloride solution. And if we're going to balance that, we've got 2 NAs, so we need a 2 there, and then we need 2 HCls to go along with that. Okay, so we are balanced. That is step 1 taken care of. Our next step is converting from grams to moles. So we're going to set that up for the sodium carbonate. And we're going to do moles is equal to mass over molar mass. And let's see, we're given 50.0 grams. And the molar mass, if we calculate that for sodium carbonate, is 105.99. So doing the math then, that gives us 0.4717. Whoops, that should be a 7, not a 4. Moles of sodium carbonate. You want to keep this number in your calculator, or you want to keep at least 4 non-zero decimal places to avoid rounding errors. Okay, so we've done this step. Now we need to set up our mole ratio. So let's do that. We are, and let's maybe highlight this, we're looking for moles of sodium chloride. So we're looking for that one there. And we're given our sodium carbonate here. Okay, so now that we know, on the left side, we're going to set up our mole ratio with what we know from our balanced chemical equation. So 1 mole of sodium carbonate reacts to give 2 moles of sodium chloride. And then we're going to use our known value we just converted there, so 0.4717. For some reason, I keep wanting to write a 4. I'm not quite sure. And then we've got X moles, and this is sodium carbonate, and this is our sodium chloride. Do a quick double check here. Make sure your sodium carbonates are both on the top, your sodium chlorides are both on the bottom, or if you set up your ratio the other way, just make sure that the same thing is on the same thing on each side of your equation. So from here, cross multiplying, 1 times X is equal to X, and then 2 times 0.4717 is going to give us 0.9434, so on, moles of sodium chloride. Again, do not round off here. We are not done the problem yet. And you will end up with rounding off errors if you round off too early. Okay, so now we need to do our last step here, and that we need to find the number of moles. So we're going to look at our answer, and our answer is already in moles. So there's nothing else we need to do here other than round off for significant digits. So 3 significant digits in our question means that the moles of sodium chloride produced is 0.943 moles of sodium chloride. That is rounded off for 3 sig digs, and that's the question, and we're done with that one. Let's look at one more example then. So how many moles of oxygen gas will be produced by heating 400 grams of potassium chlorate? Okay, getting the highlighter out again. We are looking for moles of oxygen gas, so that is here. And we are given 400 grams of potassium chlorate, which is here. So the first thing we need to do is start with balancing our chemical equation. You can see we have 3 O's and 2 O's here. So if we use a 3 here and a 2 here, that's going to balance our oxygen. And then we need a 2 here to balance the potassium and the chloride. Now that we've done that step, we're going to convert from grams to moles. So this is for the potassium chlorate. We're going to do moles as mass over molar mass. And we're given 400 grams. And the molar mass of potassium chlorate is 122.55. So that gives us 3.2639, so on, moles of potassium chlorate. Now, we want to set up our mole ratio to find the number of moles of our unknown substance. So taking from our balanced chemical equation, we know 2 moles of KClO3 reacts to produce 3 moles of O2. And then we calculated 3.2639 moles of KClO3. And we're trying to find our moles of oxygen. So doing some cross multiplication, we end up with 2x is equal to 3 times 3.2639. So that's 9.7919. And then dividing both sides by 2 is going to give us x, which is 4.8959, and that's moles of oxygen. Now finally, looking at our question, we have 3 significant digits here because that decimal place means all 3 are significant. So rounding off to 3 significant digits means that we have 4.90 moles of O2. And that is that problem solved. So no matter the reaction, grams to moles stoichiometry is always going to follow those same steps. It's going to do balanced chemical equation, then convert the grams to moles, and then use a mole ratio to find your moles of your unknown. In the next video, we're going to extend the same method to solve gram to gram stoichiometry problems. That video is linked on the screen now and in the description below. Go check it out, and we'll see you there.